Okay, so we've got a question here. We're going to try and solve the boundary value problem of this functional here. And this here is our boundary value conditions. So from 0 and to 2, it is 0. So at those points. So now what we're going to try and do is try and find y of x from this functional. Now in the previous video, we used the Rayleigh Ritz method. In this video, I'm going to try the Euler Lagrange to give us a differential equation and then try and solve the differential equation with these boundaries. Okay, let's go straight into it. So the Euler Lagrange equation, that formula is the derivative with respect to x of the partial of s, that's our functional, with respect to y prime, and then we subtract the partial of s with respect to y, and as it's always the stationary positions that we're interested in, we're going to set it equal to 0. Okay, now we can do that with our functional here. So we'll go d dx and then the partial of s with respect to y prime. Well, this is the only term with y prime, so then we've got 4y prime there. And now we need to subtract the partial of s with respect to y. So there's two terms. So I'm going to put a bracket there. Now this minus is still this coefficient here. So when we take the partial of this with respect to y, we don't want 6y, we want minus 6y. So that's minus 6y. And then this one here, the x will be the coefficient, y will disappear, so we're just left with x. And then that is equal to 0. Okay, so just tidy this up now, get rid of these minus signs and take the derivative here. So we're left with now, well, the derivative of 4y prime is now 4y double prime. They become a positive, and to put that negative in there, we now get minus x, and that equals 0. So I'm going to write our Euler Lagrange equation up on the board here, rub this off, and then we'll try and solve our differential equation. So 4y double prime plus 6y, and then that equals x. Okay. Okay, so next step, let's try and find our solution. So y of x equals the homogeneous version plus the particular version. So our homogeneous version is when we set the left hand side to equal 0. So we want 4y double prime plus 6y equals 0. And this is for our yh of x. Okay, now we can solve this using our auxiliary function. So we can go straight into that. So 4r squared, as that's the second derivative, and then plus 6. And that is equal to 0. Okay, let's try and solve for r. So 4r squared equals minus 6. R squared equals minus 6 over 4. So then we can factor that out a little bit. So that's minus 3 over 2. Take the square root on both sides. So our solution is r equals plus or minus I square root of 3 over square root of 2. So therefore our homogeneous solution h of x equals, so we need a constant, and we'll do sine first, and we'll use this value here. So instead of imaginary, we don't need that, we just put the square root of 3 over 2, multiply that by x, and then add the cosine version, and that fits in there just. Okay, right, now let's find the particular solution. So this time we need the x. So yp of x equals x. Okay, So now we need a trial function to plug in for our y prime and y. So we'll let our y, we'll just call it the trial function, equals cx plus d. So it's going to be of that kind of format. So now we need to try and take our second derivative to plug into here, because our y here, we can just plug in this. So now y of our trial function, our second derivative, well, if we take the second derivative of that, that's just 0. So that's pretty straightforward. So now we can plug these into here and then see what we can do with corresponding coefficients. So y double prime, that is 0. So continuing down in here, plus 6 times cx plus d. And that equals x. Okay, now let's just simplify that out and try and get corresponding coefficients. 6cx plus 6d equals x. Well, there is no coefficients here, so our d is 0. So d equals 0. That's fine, so we can ignore the 6d. But now 6cx equals x. So that basically gives us 6c equals 1. So therefore c equals 1 over 6. That's pretty straightforward. Okay, so therefore our solution here is, for our particular solution, yp of x equals c times x plus d. So that's x over 6, and our d is 0. So let's just write that up in there now. P of x equals x over 6. Okay, right, I'm going to take this off the board, and now we're going to try solve it using our boundary conditions. Okay, so our function here for y of x, that equals a times sine of root 3 over root 2x plus b times cosine of root 3 over root 2x, and also we need to add on the particular, which is plus x over 6. Okay, boundary condition time. We need to try and use y of 0 equals 0 first. That's going to be our easiest place to start. So y of 0 equals 0. So now we're going to plug in for our x's, all zeros. Well, we know that sine of 0 is 0, so this whole term will cancel out. So I'm just going to put a 0 there just to show that we have cancelled that. And here, root 3 over root 2 times 0 would just be 0. And cosine of 0 is going to be 1. So therefore here we can write b times 1. So 1b, or I'll just leave it as b. And here x over 6. Well, if we plug in 0 for our x, we just get 0. Okay, well, if b plus 0 equals 0, b can only be 0. So therefore b equals 0. That's our first coefficient solved. So now we need to calculate y2 equals 0. Now that we know that b is 0, this is going to make things a little bit easier. So y of 2 equals 0. Okay, so where we see an x, we plug in a 2 and try and get the whole thing set to 0. So we've got a times the sine of root 3 over root 2. Now we've got a 2 here, but as we've got both radicals inside, I could plug in a square root of 4 in there. That would still be the same as 2. So root 3 over root 4. B is 0, so this term disappears. And now I'm going to add 2 over 6. So that we know is a third, but we can write that on the next line. Okay, so now we've got 0 equals a times the sine. Now can we simplify this off? Now using laws of radicals, root 3 times root 4, well that's root 12. and divided by root 2. 12 divided by 2 is 6, so we can plug in the square root of 6 there, and then add 1/3. Okay, what can we do here? Well, we can bring our 1/3 over to the other side, and then we can see if we can try and solve for a. So we've got -1/3 equals a times the sine of root 6. So now if we divide both sides by this sine value, we'll leave a on its own. So now we've got -1/3 times the sine of square root of 6. That equals a. So now we've got our a value. So we've got b equals 0, a equals negative value, -1/3 times sine root 6. Okay, now this is an actual constant here. This is a value, because sine of square root of 6, we can type that in our calculators, and that will give us a value, multiply it by 3 and take the negative reciprocal. That's going to give us our a. So now we can write down our function now of y of x, our homogeneous plus our particular. So now we can have y of x equals -1 is our a divided by this, so that can then be minus sine of square root of 3 over square root of 2 times x divided by 3 times sine square root of 6, and then we can add on x over 6. So that's going to give us our value for our y of x. So let's just take these off the board now. So y of x equals, so I'm going to bring my x over 6 to the front, x over 6, and then keep the minus sign in the middle. Now I can write this. So it's sine of root 3 over root 2 times x divided by 3 times the sine of square root of 6. Now that is a valid answer. That all looks good, but we could